Assalamu alaikum. My name is Kainat Abasi and my roll number is 16TE83. This is our fifth lecture of digital signal processing and we will continue it from our previous lecture, that is basic operations. We learned about inverse system, scaling system and shifting. Now we will apply all of these operations simultaneously on a system. Let's say the system is y of n is equal to x of minus 2n plus 3. First of all, we will apply shifting, then inverse or mirror, or we can also say flip, and then scaling. If I will write it, we can say, let's say u of n is equal to x of n plus 3. This is shifting. And w of n is equal to u of minus n. This is inverse system. And y of n is equal to w of 2n. This is scaled version. Let's say if x of n is equal to 1, 2, minus 1, 2, 0, 1, 1, 3, and this is our 0th point. This is 1, this is 2, this is 3, 4, 5, and minus 1 and minus 2. First of all, find u of n, that is shifted version. It is shifted 3 times. We can say 0 is shifted 3 times. So u of n is equal to 1, 2, minus 1, 2, 0, 1, 1, 3. Now 0 order is here. Previously it was here, it is shifted 3 times. Number second is inverse. Find w of n, that is u of minus n. I told you, you can simply write the inverse system in this direction, that is flip around the 0 value. Start from this 3, 1, 1, this is 0th point, 0, 2, minus 1, 2 and 1. This is your inverse system. And number third is scaling. Finding y of n, w of 2n. This is index scaling. And multiplication here indicates compression, that is our original system is compressed 2 times. That is, this is 0th value, and after 1 point the values are retained. You can also verify this by putting 1 by 1, each value 1 by 1. 3, 1, this is 0th point, 2 and 2. So this is our y of n after applying all 3 operations: shifting, inverse and scaling. Now move toward second thing. If an input signal is given and if an input and output signals graphs are given, how can we find the system? For example, if x of n is equal to minus 3 minus 2, इनका मैक्सिमम एम्पलीट्यूड हमारे पास 1 है, minus 1, 0, 1, then 2 and 3, and here it is 1 and 1. If x of n is this and this is input signal and this is our output, that is response, is something like this. At minus 3 it is 1, then 0, then minus 1, 0, 0, this is 0, 1, at 2 it is 1, at 3 0, and at 4 it is 1. This is 1, 1, minus 1, minus 1, and they are all 1. How we can find our system? if x of n is an input to a system and y of n is output, we have to find the system. We are given the input and output. This is very simple system. We can write y of n is equal to x of n minus x of n minus 1. If we shift the original system one time, then we can and then taking the difference we can find the output. Let me verify you. X of n minus 1, n minus 1 is 0 and n is plus 1. The original system is shifted one times. 2 plus 1 is 3, 3 plus 1 is 4. Here we have 1 amplitude, and minus 2 plus 1 is minus 1, minus 3 plus 1 is minus 2, 1 and 1. Now taking the difference of these two signals, we can find y of n. This start from minus 3 to maximum value 4. Minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. At minus 3 it is 1, here it is 0. 1 minus 0 is 1. Minus 2 it is 1, 1. 1 minus 1 is 0. At minus 1 it is 0 and 0 minus 1 is minus 1. Here it is 0 and 0, 0 and 0. Then at 1 minus 0 is 1. 1 minus 1 is 0 and at 4 it is 0. 0 minus 1 is minus 1. So we get this. So our system is x of n minus x of n minus 1. This is the simplest system. Now moving towards third thing, what is impulse response and how to find the impulse response. If the input signal is an impulse signal, we can say if a system is fed with impulse system, then the response obtained from the system is known as impulse response. And how to find the impulse response of a given signal. Let us suppose the system is y of n is equal to x of n minus x of n minus 1. Replace the input signal with delta sub n, that is impulse signal, and response with h of n. H of n is known as impulse response. Delta sub n minus delta sub of n minus 1. And here remember one thing, delta of 0 is equal to 1 and otherwise delta is 0. Only when here n is 0 it is 1. So starting from minus 1, h of minus 1, delta sub of minus 1 minus delta sub of minus 2, which is equal to 0. H of 0, delta sub 0 minus delta sub of minus 1, this is 1 minus 0 is 1. H of 1, delta sub of 1 minus delta sub of 0, that is 0 minus 1, which is equal to minus 1. And h of 2 is delta of 2 minus delta of 2 minus 1 is 1, means 0 minus 0. So we can write h of n is 1 and minus 1. This is 0 or index, and this is at 1. And a very basic thing is using delayed scaled version of delta signal. Delta signal means unit impulse signal. We can construct any arbitrary signal. Let us prove this statement. If x of n is 2, 3, minus 1, this is 0th order. How we can construct this signal using an impulse signal? This is 0, 1 and minus 1, means this is delta sub of n plus 1, delta sub of n and delta sub of n minus 1. Shifted, yeah, we can say delayed version of delta. Delta sub of n, delta sub n is here 0, multiply by 3. We will get at 0 3 amplitude. Delta of n minus 1, that is of 0 minus 1, multiply by minus 1. This is equal to minus 1 at n minus 1. N minus 1 is 0, n is 1. So at 1 we will get minus 1 amplitude, and similarly n plus 1 multiplied by 2. N plus 1 is 0, n is equal to minus 1. So at minus 1 we will get 2. If we sum all these signals, delta sub of n plus 1, delta of n and delta of n minus 1, we will get x of n. How? Number 1 signal was at 0, 3, at 1, minus 1, 2, and at 1, minus 1. If we add these three signals, these are at 0, 1 and minus 1. At minus 1 we have 2, simply 3 and minus 1, 2, 3, minus 1. So we can write y of n is equal to 2, 3 and minus 1, and this is 0th point, and it is similar to given signal. So using impulse signal we can construct any arbitrary signal. And a second example of impulse response, in which impulse response is involved at input. Let's say the system is something like this. We will replace y with h of n, 0.5 h of n plus 1, and x of n with delta of n. And we will assume here a relaxed condition. What is a relaxed condition? It means before 0 the system response is 0. Starting from 0, h of 0 is equal to 0.5 h of 1 n minus 1. This is correct, this mistake. H of minus 1 plus delta of 0. And I told you that before 0 the system is at 0, so this will give us 1. 0 the system is 0. Okay, h of 1 is equal to 0.5 h of 0 plus delta sub of 1, and h of 0 is 1. This means 0.5 multiplied by 1. This is 0, means 0.5. H of 2 is 0.5. H of 2 minus 1 is 1 plus delta sub of 2. This is 0 and this is 0.5. 0.5 multiplied by 0.5 is 0.25, and we will get something like this. 0 1, this is 0th point, 0 0.5, 0 0.25, 0 0.125, and so on. So here we will conclude one thing. When the output response, yeah, impulse response is involved at the input side, the overall response is infinite. And when the impulse response depends only on the input response, input signal, the overall response is finite. Here we learned about the basic operations simultaneously, and about the impulse response, that how we can construct any signal using an impulse signal and how we can find the impulse response. Thank you very much.